Hey everybody, this is Larry. This is day 24 of the Leetcode Day Challenge. I don't have to wait for it. I know what today's day is. But yeah, hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. Today we have 1975 maximum matrix sum. Also an update. I'm about, not quite 48, maybe 46, 45 hours into my dry fast, meaning no water, no food, no nothing. I'm gonna break it soon. Originally I wanted this to be just a regular water fast, right, with water, but I felt kind of good. I mean, I didn't sleep enough, so that's another story. But I did take a nap, so I feel a little bit better. But my eyes are just tired. Like my body feels fine, but my eyes are a little bit tired. I think I need eye drops. They're a little bit dry, but we'll see how it goes. So if I'm winking or blinking a lot, my apologies. But yeah, okay, today we have 1975 matrix or maximum matrix sum. So you're given an n by n matrix, you could do the following operation any number of times. Choose any two adjacent elements of the matrix and multiply them by -1. Okay, two elements are considered adjacent, they consider share a border. Return the maximized summation of the right? Okay, so you could look at any two numbers and any two adjacent two numbers and do negative and multiply by -1. There is kind of a, I think this is a key thing. I mean, I know that I've been talking and hopping on about invariance lately, and it's still true, right? And for this one, what does it mean, right? Well, what does it mean is that for every two operations, you could kind of think about it as composition of operations, right? And here is that there are two adjacent ones. What does that mean? Well, what does two moves mean, right? Actually, I was going to just draw it. Let me draw it out. Hang on. And what that might mean is, this is from the morning. Actually, I guess I didn't clear it. What that might mean is that, okay, let's see, right? So you have a grid. A terribly drawn grid. I need like a grid copy and paste in so I don't have to keep making this mistake. But let's say, we have this, and, without loss of generality, I guess we can put any two. And then now, let's say you want to, quote unquote, move one of them, right? Well, what did that look like? Well, that means just swapping this. So we remove this and then put it here. And then now we can also move this and put it here. And then we can move this and put it here. And then we can move wherever, right? So that means that without a loss of generality, so you start the board with 0, but you can actually slowly move one of the piece any each way. And of course, you can just keep the amount, right? Meaning that you can keep these two here, and then you can do the next two, and then you can also move them around if you like, right? Or I guess technically you have to do the next two next to each other, but then you can move them, one of them, and then move the other one, right? One step at a time. And so this is a long way of saying you can now flip two numbers at a time, right? Note that this cannot, go. You need to. The invariant is the parity, and the parity is that there will always be two of them. Or even number really, but two at a time, right? And for example, if you have two adjacent ones and you just kind of try to move this one step, then now they kind of cancel each other out, kind of thing. So okay, so with that being said, what does that mean, right? Why is this like, okay, so what does that mean, right? My mouse is acting weird. What does this mean? So what this means is that, well, what does the rest of this mean? For this, we can say, two adjacent elements and multiply each of them by -1. So then now what we want to do is that they don't have to be adjacent anymore, right? Now we're just choosing any two elements and then multiply them by -1, and we want to maximize the sum. So of course, in maximizing the sum, we can choose greedy, right? And I know greedy is maybe intuitive for all these things, and today on the bi-weekly, for me is today, even though I did take a nap in between, the bi-weekly where I had a greedy problem that I just struggled on because I greedied the wrong way. So greedy problems can be very hard, and here's the mini proof, right? The mini proof is just that if you have, say, 4 numbers, A, B, C, D, right? And you have A is less than 0, B is less than 0, right? And it doesn't actually matter what C, I guess for this case, C and D doesn't really matter, right? But you can easily see that A plus B is going to be less than 0. And then if we flip the signs of them, then A is going to be greater than 0 and B is going to be greater than 0 and A plus B is greater than 0. So yeah, so this is after A plus B, right? I mean, this is a very silly, obvious flip. And you can kind of do the math, right? Or not do the math, but I mean, this is very obvious, but be case analysis. And we can also say that without loss of generator, A is less than B. So then now there's really only 2 more cases, right? Which is, okay, great. Well, the other case is more obvious as well, is that if they're both positive, then, and then after flip is going to be A plus B, right? After flip it's going to be less than A plus B. So we never want to flip 2 positives. And then the third case is A is less than 0 and B is greater than 0. Remember that A is less than B, so this is the only other case. But you can do mirror stuff if you like. And then now, what does this mean, right? Well, if absolute, you can break this down to 2 cases as well. If absolute value is less than absolute B, right? Then what happens? Then that means that, well, you can just sum it up, right? So you have A plus B is it greater than or equal to 0, right? That's the biggest question. Because if it was greater than 0 before, then after it is going to be A plus B is less than 0. And then of course, by the same token, if A plus B is less than 0, then afterwards A minus B is going to be greater than 0. And I guess you can do some maths of absolute value by putting on both sides, but it's obvious that if you want to go from this to this, wait, why do I have minus? This is confusing. Okay, afterwards A plus B is greater than 0. You want to go from negative to positive because, So okay, so maybe this is like a very lazy proof, a very quick proof, not a very rigorous proof, but I just want to show you that this gives me the idea to be right? So okay, so now we have matrix, and now we can just have one flattened array. So maybe I have something like this, right? So for row in matrix, array.extend row, something like that, and then we can just sort. Yeah. And this works. I guess I was just trying to think about, because at most by pigeonhole, right? At most you can have one case where you have one positive, one negative, right? But that case will be that case, if you do it in a greedy way, will be the smallest, the smallest in absolute value in the negative one and the positive one, right? Because for positive side, it doesn't make sense to choose any other ones, and does it all? And in a greedy way, it doesn't make sense for the other one. Though I think you could do like you have to do an exchange argument to prove that to be more precise. Because if you have like 3 elements, if you get to choose A, B, C, D, right? And I guess this part is actually not super intuitive to me. That's why I'm like pausing and waiting. But if you have A, B, C, D, right? A is less than B, is less than C, less than D, right? And D is greater than 0, C is less than 0, right? Then in this case, do you always want to choose A, B? You flip A, B, and then flip C, and then check on C, D? Or would you do flip BC and then check AD, right? I guess those are the 2 school of thoughts, and it all comes down to, okay, so B, in this case, the B doesn't come into play, right? So you might as well as remove it, right? And the reason is because we just flip B no matter what, right? So then now it becomes, A, C, and D, right? which I guess there is some like loss without generality. You could say this is AB, whatever, right? But I just keep it the same variables. Okay. Because in both these cases, you just flip B anyway. So then in this case, yeah, and it assumes that this is the only choice we can make, right? Because obviously, if you only have 3 numbers, you will always choose A and C, right? But okay, so then now the question is, so before the exchange argument, the A plus D is going to be less than A plus C, right? So before flip, right? Because C plus D, whoops. We know this because A is less than C, right? So we just add D on both sides, and D being a positive number, but it doesn't matter, right? It's one number, so it will be C is less than A, which we already know, but because it's here, but it's just put another way, right? So, okay. So then after flip, A plus D is going to be greater than C plus D, and so A is greater than C after the flip, so we always want to choose A, right? Is this the right argument though? No, you're dumb, Larry. I think I'm just confusing myself. Okay, so let's say you have 4 numbers, right? And I guess my thing was saying that my thing is not to swap between these two. I think that was the wrong thing that I was thinking of. This is why greedy is hard. I mean, it might be right, but it's hard to kind of, make sure you're right on edge cases, right? And then now, the question isn't whether you choose, because my idea was that whether you choose A, B, and then C, D, right? Or C plus A, then, B plus C, and then A plus D, and then do the check, right? Because this is kind of like silly, because all it's saying is that you have 4 numbers. What it is saying is that whether A plus B plus C plus D is better than A plus B, right? Or B plus C plus D, maybe? Because basically, oh no, that doesn't make sense either, right? Basically, okay, so let's say this is to take the C no D, right? And that part, I think it just, like we said about the C and D, right? Whether it's positive or not. But then, is there a case in which... No, because in every case, you just swap the D. Okay, so I think we're good here. But sometimes proofs can be hard. Okay, yeah. So then now for x, y in array, right? If x is less than 0 and y is less than 0, so total is equal to 0, right? Total... Oh man, I'm being really silly. Right, alright, let's just do it this way. Length is equal to array, right? For I in range of 0 and 2 at a time, right? And then if array is less than 0 and array of I plus 1 is less than 0, then yeah, we just trivially just flip it. Maybe today I'm just not doing well, but yeah. Otherwise, else if is less than 0 and and then that's pretty much it. I hope, because greedy is apparently really hard for me today. Math is really, everything is hard for me today. I don't know. Oh no. Did I mean, I know that I didn't consider 0. Oh, yeah, okay. In this case, it has to be... Yeah, okay. I thought that... okay, I'm just... I'm just being really sloppy today. Yeah, I mean, I'm rushing it a little bit as well. So, okay. This is just terrible. I'm rushing it. I don't know what to say. Sorry, friends. I am having a bad day. But the logic still makes sense. It's just that, yeah. Yeah, okay. Just a couple of silly edge cases. I mean, this one I should have known. I don't... I thought I saw an example. Like, why would I not... Oh, because this is not true. So then this is not true. So, yeah, okay. I thought in my mind, I thought I tested odd number for that reason. But yeah, I realized that I actually didn't because of this if statement and this other thing. And also, usually, I write it backwards for that reason. But like I would write I+1 here so that if it messes up, I would know no matter what. But yeah, silly mistake. And then the other wrong answer is just, what was this again? Oh yeah, I just forgot to consider 0. I was thinking like Larry remember 0. And then I was like, oh, in this case, it's without loss of generality. But in this case, it is not. I think technically it should be this one. If they're both, you go to... I think this one is fine too, but I think this one is more... more true, I think. Maybe, yeah. What did I do last time? Oh, I count the number of negatives. Oh, I see. So I guess you didn't need to sort. Past Larry is so much smarter. Today, Larry, not so much. Yeah. I mean, the sorting thing kind of makes sense because we're just going down. But basically, this is saying that at most, we're not... So at most, because we want to use all the negative numbers except for at most one of them, right? So total is total. If negatives is that means that if they're even number of negatives, then we just turn all of them. If they're odd number of negative, we get the smallest of the thing. We get the smallest of the values, right? Man, I mean, I see that we get the smallest of the values, but this is kind of confusing. Past Larry is way smaller than current Larry, so I don't know. I hope I have a video, and if I did, then you check that out. But I mean, the logic kind of goes from the same place. Today I saw it because the greedy kind of makes sense. But here, if you take the observation one step forward, is noting that only one of them cannot be flipped, and you try to choose the smallest one. And in that, you get the two, yeah. And the reason why this works is because if you do the math, if we just sum all of them, then the negative gets double counted, right? You could kind of do the math that way. Because we're adding the positive value. So we assume we already added the positive value, and then you kind of subtract the negative value out twice for flipping it. It's kind of this is too clever for me. I don't have the brain power for this. But yeah, in this case, this is going to be linear time, linear space, right? That's the size of the input. Actually, this one is actually not even linear space. It's even so clean. Past Larry's too smart. Yeah, it's going to be linear time, constant space, much cleaner. Today, this is actually, I did do linear space because I make a copy and then I sort. Really, and I had two wrong answers being sloppy. So, really sad. But future Larry, if you're wondering, you are on a really long dry fast. And yeah, so I blame it on that. But that's all I have for today. The contest is in about 40 minutes, so wish me luck. But besides that, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.